Number 3, we have this data. We're going to go plot it in Desmos and then try to find the line of best fit for it or the curve of best fit. Now, looking at it, we have a couple of things that we're dealing with here. We have exponential growth, where something grows very quickly, almost becomes a vertical line. It's growing so quickly. You have exponential decay, where something shoots down very quickly, starts reaching to zero very quickly. And then you have a log, which sort of goes like this. As the data goes on, it takes a while for it to grow. It grows very slowly. Looking at this data, it's going 0.8, 0.64, it's getting smaller. So it really isn't growing, is it? That tells me it's this guy, exponential decay, where what we're going to have is y equals some value here, we'll call it the a value, times some fraction raised to the x power. Okay, not necessarily a half, but it's a fraction in there because it's not growing by more than one, it's actually decreasing. So we need to go to Desmos and plot these numbers. So we go over to Desmos. Now, to plot it, to put it in a table, you hit the plus key, you hit the table. I already did that. I already entered them for us to save time. There they are. Now, you can see them over here. They're sort of spread out and a little messy. Something doesn't look right. Looks like I typed something wrong, which I did. That right there was, according to what I'm seeing, is 0.8. I typed 0.08. So let's back up, back, and put in 0.8. And now close. Look, much better. And yes, we can see this line looks like exponential decay. It's so there was a little thing I picked up on because the dots didn't look like something was off. So how do we end up getting the equation? Here's what we do. I know it's exponential decay, so I'm going to enter that type of equation. So I'm going to enter, let's just pull up our board here. We'll do it here. I'm going to enter y, and I need my little squiggly. Now that's on my keyboard. It is in here somewhere, but to be honest, I don't know where she is. So I'm going to just go ahead and use my keyboard, and I'm going to hit shift in the little squiggly. Oops, put it right there, shift in the squiggly. Okay. Now again, exponential decay is going to be an A. And I can get it here. I can type this A times, I'm going to go back to my numbers, and I want to enter times just because I like to, times B to the X. So I need a B. So we're going to go back and grab Mr. B, if we can find him. B. Back to my numbers. I want to raise it to a power. So I'm going to raise it to an X. So I hit this AB button, and then I'm going to type X, but I need to tell it that I'm using my data. Now notice I didn't do that back here with the Y. It was Y sub. I need to hit a 1 there. Bad me. Just like this, needs to be an X, and I'm going to hit the 1 there. Now it realizes, hey, this guy wants us to try and find a curve of best fit. And so it knows to go use the data. That's why you're using Y sub 1 and X sub 1. Okay. So we enter this. It now is going to give us, look how beautiful it is. It's almost a perfect fit. Let's look. Maybe it is. Let me close this out. The R squared value, the correlation coefficient says, hey, you're a perfect 1. You're perfect. Your A value is pretty much a 1, and your B is a 0.8. So if we come back, it's Y equals a 1 times the B value is 0.8 to the X. You really don't need the 1 there because 1 times anything is whatever, but it's okay to have. So this is basically the equation. The best line of fit is Y equals 0.8 raised to the X power.